Welcome to Homework Lib.
Okay, so domain of this function is all real numbers. Okay, range of this function is all real numbers. That's because you have x cubed, so you're going to positive infinity on the right, negative infinity on the left. Okay, we need intercepts. Y-intercept is going to be 0, 0. X-intercept, I'm going to factor out an x. Okay, that is not going to factor, so I'm going to need quadratic formula. So my x-intercepts are going to be at 0. Let me just calculate these. So what do we have? 1, -3, and -45. So I am going to have for my x-intercepts -5.374 and 8.374. Okay. Now, critical numbers. So I'm going to need my first derivative. That's going to give me 3x squared minus 6x minus 45. I'm going to set that equal to 0. I can factor out a 3. Okay, so I'm going to get, let's see, x minus 5 and x plus 3. So my critical numbers are 5 and -3. Let me write critical numbers. Okay, so I want to know increasing, decreasing. So let's put those on a number line. Pick some test points and see what's going on. So I'm going to just pop this into my calculator because it's late here and I don't want to make any careless mistakes. Okay, so if I put in something smaller than -3, like -4, I'm going to get out something positive, which means my graph is going to be increasing here. 0 is going to give me a negative, so I'm going to be decreasing here, which means I'm going to probably be increasing, but let's double check. Yes, I'm going to get a positive here. I'm going to be increasing. So this is telling me that I'm going to have a relative max at -3 and a relative min at 5. Let's get y coordinates to go along with those points while we're at it here. So I'm going to put those values back into my original function. Okay, so let's see what we got. If I put in -3, I'm going to get out 81. If I put in 5, I'm going to get out -175. Okay, so my graph, let's just write these intervals down for increasing and decreasing, will be increasing from -infinity to -3, and then from 5 to infinity. It's going to be decreasing in between -3 and 5. Okay, concavity. Concavity requires second derivative, so let's do that. We're going to get 6x minus 6. I'm going to set that equal to 0, and I'm going to get x is 1. I'm going to plot that. So let's see, if I put in 0, I'm going to get out a negative, which means I'm concave down. If I put in 2, I get out a positive, which means I'm concave up. So I am concave down from -infinity to 1, concave up from 1 to infinity. Because I have that change in concavity, I have a point of inflection at 1. Let's get that y coordinate. It's going to be 1 negative 47. Okay, so let's see. Let's get a little sketch going. This is not going to be great because I don't have a lot of room, and these are kind of big numbers. But I know the important stuff, I'm going to be negative 10 to 10 here on the x-axis. So I have an intercept. Let's see, that's negative 5. So I'm going to have an x-intercept here and an x-intercept here. I know my ends are going to be going up and down. And I have a relative maximum at 81. So I'm going to count by, let's say, 40, 80, 120. So I'm going to have a relative maximum at negative 381. So about here. And then I'm going to have a relative min halfway here. So there's 5. And if I'm counting by 40s, 40, 80, 120, 160, 200. So that's going to be down here. And I'm going to come on up. And then you can see that you do tend to have that change in concavity somewhere between positive 1 and negative 5. So right around here you have that concavity shift from concave down. Maybe you want to make it a little more pronounced, to concave up. I hope that helps.